Alhamdulillah Rabbil Alamin. Today also we start another class. We say thank to Allah subhanahu wa ta'ala. We are dealing with hydro-organic chemistry, yes? And organic chemistry, we are looking at hydrocarbons, yes? What do we say are hydrocarbons? Hydrocarbons is a compound, a molecule that contains only carbon and hydrogen, okay? So if there is a compound that contains hydrogen and carbon only, we say it is a hydrocarbon, okay? But if it contains another element like oxygen, okay, like alcohol, yes, like alcohol, okay, or carboxylic acids, okay, or esters. We are going to cover all this. Don't be mesmerized by this. Alcohol contain this group there, okay. Carboxylic acids contain COOH in it. Yes, this one contain what? Huh? Yeah, contain something like that. I forget, yeah? But they are not hydrocarbons because they contain oxygen in it. So hydrocarbons contain only carbon and hydrogen. Now, under the hydrocarbons, there are many types of hydrocarbons, yes? The one we first look at, the first one is alkanes, okay? Alkane. Alkanes are hydrocarbons which have only single carbon to carbon bond, meaning carbon is attached to another carbon or another hydrogen only by a single bond in it. So between a carbon and another carbon, there's only a single bond. Okay, we know carbon can make 4 covalent bonds, yes? In the atomos cycle, carbon can make 4 covalent bonds, yes? Okay. So one hydrogen can attach here, one hydrogen can have a covalent bond here, another hydrogen can have, that's what we mean, yes? But carbon can have a double bond, carbon to carbon can have a double bond. So that is different name, that's called alkene. That's not what we are doing right now. What we are doing now is alkanes, yes? We say alkane are principally found in crude oil. And when we talk about crude oil, we remember Saudi Arabia, because crude oil contains a lot of chemicals. When we finish alkanes, before we look at alkenes, which are double bond, we are going to do fractional distillation and cracking. Okay? So that's going to be our last. We don't want to go over this again because we have done that in the previous years. But suffice to say, we have ethane, okay? We have propane, we have butane, we have pentane, okay? We have hexane, yes? Hexane. Yes, ethane means 2 carbon to carbon bond. Propane means 3 carbon, yes? Butane means 4 carbon in it. Pentane, 5 carbon, yes? And hexane means 6 carbon. Okay? They are all joined to hydrogen. Okay? Pentane, 1 more carbon, yes? Butane, 4 carbon, yes? Yes. So each of that is hydrogen, okay? Each of the covalent bond there is hydrogen. Okay? We say this is ethane, propane. Propane means 3 carbon. Butane means 4 carbon. Pentane means 5 carbon, and hexane means 4 carbon. And we said this can extend to septane, nonane, decane, up to 10, up to 200 carbons, yes? But suffice to say, as we say in the last one, yes, as the molecule of the number of carbon increases, this ethane change from gas to liquid, yes? From gas to liquid, yes? And ultimately to solid. An example of solid is bitumen. Bitumen is used in tar. We are just going over what we have done the last time, okay? Just to paraphrase what we have done last time. Now we said the state of the alkane changes from gas to solid. Okay, we say the state of matter is gas, liquid, and solid. So as the number of carbon atom increase, okay, it will change from gas to liquid, then to solid, okay? And we said we are going to, that's the basis of cracking, okay? Cracking just means dismantling the long hydrocarbon into smaller molecules, yes? We are going to look at that. Now, before we look at fractional distillation and cracking to finish alkanes, we're going to look at naming them, okay? Naming alkanes. Naming alkanes. And what we said, they call it nomenclature, in it. We call it nomenclature. Okay. First of all, if you look at this, what do we call this one? Yeah? Methane, yes? Methane, yes? And this one, we call it ethane. Okay. So if this is attached, this is attached to a group, we will say a methyl, we call it a methyl group, in it? Methyl, yes, we call it a methyl group. So if this is attached to a long hydrocarbon, long chain hydrocarbon, we will call it an ethyl group. You come to understand what I mean, okay? Ethyl group, okay? So now, let's say we have a long hydrocarbon like this, okay? So, what will you call this one? What will you call this one? Butane. Why? Because it has 4 carbon. Yes. So if you look at all of them, they all have how many covalent bonds? 1, 2, 3, 4 in it. 1, 2, 3, 4. All of them has 4 covalent because carbon can have 4 covalent bonds. But assuming we have it like this, we have 1 carbon join here. What would you say?
It's pentane.
It's still, no? That's the trouble here, there. Still, you look at the longest chain. Longest chain is 1, 2, 3, 4 in it. 1, 2, 3, 4. Either way you count it, you'll have 4. Okay, so it's still butane because the longest chain is 4 carbon. So therefore, we have to call them, whatever we're going to name them, we call the butane. Yes? What did I say is this chain? We call this methyl? Methyl group, yes? Yes. But if you look at this 1, 2, 3, 4. If you look at the longest chain, this methyl group is in the second carbon in it. Yes. It's in the second carbon. So we call this 2-methyl butane. You see? Yes. Let's say there's another carbon here. What would you call this? Pentane. Now instead of here, we have hydrogen here. We have here. We have the carbon here. We have the methyl group here. Okay, so whatever if you look at the longest chain is the straight one in it. 1, 2, 3, 4, 5. Because here I have the 1, 2, 3, 4. So if we use this as longest chain, we are going to call this butane, and it's not. You always count the longest chain in it. So whatever happened, this one, it will be pentane in it. So we look at the methyl group is only what carbon? 3rd carbon in it. Yes. So we are going to call this 3-methyl pentane. You see? Now assuming we have another methyl group here. Now if you look at the longest chain, in what A? 1, 2, 3, 4, 5. Still is pentane in it. Yes. still is pentane. But how many methyl group do we have? 2. So still this will be pentane. But we have a methyl group on the second antagonist. So we call it 2,3 methyl pentane. Now assuming we have more carbon here. Yes. Now we have a methyl group here. How will we call this? Now look, what do you look for? The longest chain. The longest chain is still 1, 2, 3, 4, 5, 6 in it. However you count it, 1, 2, 3, 4, 5, 1, 2, 3, it will still be 6 in it. 6 is what? 10. Hexane. Hexane. Now we look at the methyl group. On which carbon are they on? This one is 1, 2, 3 in it. Okay? 3 and 4. But if you count 1, 2, 3, still 3 and 4. You have to be careful of that. And you start here, it still be 3, 4. Yes. But how many methyl group on the same one? 2 methyl group on the what carbon? On the third carbon in it. This is the fourth carbon in it. Yes. Now let me put it in another color so that you can. This is the third carbon. This is the fourth carbon. I'm putting in the same color. Okay. This is number 3. This is on number 4. Okay. So it will be hexane, but now the name will change. Look, this is on the third carbon. We're going to tell it 3,3 dimethyl. Okay. 4 methyl hexane. Meaning 3,3 meaning it is on the third carbon and is 2 dimethyl 4 methyl hexane. Because there's another methyl group on the, yes. Do you see how it's named here? Yeah? Now, what about if there's an ethyl group? Let's say it's like this. 1, 2, 3, 4. Okay. Now 1, 2, 3, 4, 5. Okay. Now, however, when we count the longest chain, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So this is the longest chain, is the straight one in it. If the longest chain, if at all we put it that way, and the longest chain is that way, we are going to name this as 1, 2, 3, 4, 5, 6, 7 that way. Okay? Now if at all this one was not there, and this one was not there, although this one appears to be longer chain, yes, we are going to call this 1, 2, 3, 4. You call it butane. The longest chain is 1, 2, 3, 4, 5. So we're going to call it pentane. In that case, this will be an ethyl group and that will be a methyl group. Okay? So, but if this is here, now look at this. Now, we are looking at the longest chain is 1, 2, 3, 4, 5, 6. So this is what? Hexane. Hexane. Yes, but we have an ethyl group here. I mean ethane in it. So we call it ethyl, and it's only it's only third carbon in it. So we'll call it 3-ethyl and 4-methyl hexane. Okay? 4-methyl hexane. Is there anything difficult in this? It's not. We just look at the ethyl group, methyl group, what on which carbon, but we have to name it based on the longest chain. Okay? The longest chain will determine what type of hydrocarbon it is. Now, look at it. We can also have, instead of hydrogen, we have chlorine here. Okay? Okay? Now, this thing is no more hydrocarbon because it has chlorine, yes? But to name this, we are going to call it chloromethane. Okay? Chloromethane. If all the four is chlorine, what are you going to call this? Or let's say, to maintain the methane name. What will you say?
Dibromine.
No.
Dibromine.
Trichloromethane. Trichloromethane. When it is 4, they will call it methane hexachloride. Is it hexachloride? Methane. Okay.
I think in school, I remember my teacher told me if you add 2 bromines, it would be dibromine.
Yeah, that's this one because we are going to do something called bromine test. Okay? Let's say you have chlorine here. You have chlorine here. Okay?
Dibromine chlorine.
This what hydrocarbon is this? Ali? Huh? Propane, because it has three carbon in it. So the last part will be propane. Okay? But it has two exactly, 2 chlorine. So we call it 2,2-dichloropropane. Okay? 2,2-dichloropropane. Okay? How about if it has you have bromine here. You have bromine here. Let's say you have chlorine here. Okay. Let's say we have. Now, how many carbon? 4 carbon. So it is with hydrocarbon, with alkane, butane. Butane. Now, if you look at it, 1, 2, 3, 4 in it. The bromine is on the first carbon here. In it. So we are going to call this 1-bromo. 2-bromo. And 2-chloro in it. 2-chloro butane. This is how we name them. Okay? Because the bromine is in the first carbon. 1-bromo, 2-bromo, 3-chloro. Sorry, 2-chloro because 2 it's only 2 second one. Butane in it. If the chlorine was on the third carbon, how would you say? You said 1-bromo, 2-bromo, 3-chloro, butane. If there was chlorine here again, what are you going to say? 2-bromo, 1-bromo, 2-bromo, 3, be careful, 3,3-dichlorobutane. You get it? Maybe you have to do it off the camera so that I can see some of you don't understand much. We have to do it off camera. But we have to look at the form. 1 bromo, 2 bromo, 2,2-dichlorobutane. Okay? This is what called nomenclature. I'm not sure whether it is in your syllabus, but I think it's important for you to know. Is there?
I did it in class.
Yeah, that's right. That's what it means, yes? If there's a methyl group, still you'll see the same thing. You say the same thing, if there's a methyl group. If there's a methyl, that's what you will say. Okay? If there's a methyl group to this, okay? Okay? So, and there's a methyl group here, in it. Methyl group. So what I'm going to say, the longest chain is 1, 2, 3, 4, 5. So this is pentane, in it. Yes. Now look at the methyl group. The methyl group is in the second carbon, in it. So we are called 2-methyl. 3, huh? This on the third. Yeah, it doesn't matter. See? Then what? 3,3-dibromo, is it? Dibromopentane. When I was doing this, some people in the class didn't understand it much. I find it very difficult, but it's very easy. You look at the longest chain, that will bear the name of the hydrocarbon. Okay, sorry, the compound, and look at where the methyl group and the what is group 7? What are they called? Group 7.
No, because halogens.
Group 7, are they halogen? No. Halogen are innate gases, that's why you put them. Group 7, what are they called?
Alkanes.
They are gases, no? Group 7 in the periodic table, I mean. Okay? Now, we look at the word cracking. Cracking. No. What is crack? English word crack mean to break down, in it. So, but cracking in terms of hydrocarbon, especially the alkanes, means we want to shorten or break up the long chain hydrocarbons. Okay, so that we can make them into more useful forms. Because the gases or the liquids are more useful than the solid, than the long chain hydrocarbons. Okay, let's say you have H50, C50, H what? What will be H?
The formula is
Ali, the formula is NH, yes? 2N plus 2. Yes. So you put 50 where N is, what will it be? 120. Now, if you have a hydrocarbon like this, obviously this will look like a solid, in it. Yes. And in a solid, you can only make it into tar. I think in one of my notes I give to 3 years ago. 3 years ago, my notes. 3 years ago, my notes. Global warming. You know about global warming, innit? And what causes global warming? The use of, the burning of hydrocarbons, innit? Yes. So that's why in our last lesson I told you they want to get rid of hydrocarbons, yes? And do some kind of hydrogen, use hydrogen or alcohol. Okay. I said carbon, from 1 up to 3 are gases, yes? Most likely gases. Okay? Carbon C4 up to C6, most likely liquid. Okay? Carbon C15, C20, solid. And they call this bitumen, yes? That's what they use on the road, tar in it. So the gases are of more useful and more income than the one down in it. So cracking, the idea behind is is to crack or dismantle this high carbon alkane into smaller carbon alkane, yes? So that to make it more useful, yes? By doing what? By applying heat, okay? By heating, okay? So if you heat and dismantle a molecular compound, what do you call it in chemistry? You call it thermal decomposition. Yeah, thermal decomposition. Yes, by application of heat, you break this long carbon into smaller chain hydrocarbons. Yes, you can make them C2H6. Okay, you can even make it C4H what 8, no, H10. Okay, up to C5H12 in it. Yes, still, if you break it into one, these ones there's maybe some up to C10. Yes, could be useful in it. Okay, up to C10 still could be useful. This is 12 in it, 22 in it. Yeah. Yes, so this is called cracking. So cracking basically means the decomposition or the dismantling of the long chain hydrocarbons into smaller chain hydrocarbons by the use of heating.
Sir, you know the carbons from like C6, from C6 to C15, what's their state of mass?
I said that from C15 up to they are still solid, yes.
No, I mean in between C6 and C15.
Okay, look at this book, what it said. Short chain hydrocarbons are flammable, so to make good fuels and are high in demand. However, long chain hydrocarbons form thick, gloopy liquid like tar, which are not very useful. So the longer chain molecule produced from fractional distillation, we're going to look at fractional distillation, into smaller, more useful ones by a process called cracking. That's what I said is, you break down the long chain hydrocarbons into smaller molecules or smaller carbon hydrocarbons so that they become more useful in form of gas for cooking. Okay? As well as alkane, cracking also produces another type of hydrocarbon called alkenes. Yes? While you are doing thermal decomposition, you may also, in the process, produce alkanes, which are double chains, yes? Which has double carbon bond, yes? We are going to look at that. They are called alkenes. Okay? They are called alkenes. Okay? Alkenes are used as starting material which make a lot of other compounds and can be made to use polymers. We look at polymers when we do alkenes. Some of the products of cracking are useful as fuels, example petrol or paraffin, which is used for jet oil. Paraffin is kerosene. Cracking is thermal decomposition reaction, breaking molecules down by heating them. The first step is to heat a long chain hydrocarbon to vaporize them, turn them into gas. Then the vapor is passed over a hot powdered aluminum oxide, a catalyst. So cracking, you pass it over a catalyst. What is a catalyst?
It's an object that...
Okay, aluminium. Is said over aluminum oxide. Yes, aluminum oxide written are this. Yes. So the long chain hydrocarbons molecules are split apart on the surface of a speck of a catalyst. This catalytic cracking heat. This is called catalytic cracking. So there's one method called catalytic cracking. That is passing over a catalyst. Yes, catalytic cracking. Okay, catalytic cracking. That's passing over a catalytic. Yes. You can also crack hydrocarbon if you vaporize them, mix them with steam, and then heat them to a very high temperature. This is known as steam cracking. You have come across this, yes? Steam cracking. Okay, this is in cell. This is called cracking. So basically, what cracking means is breaking up long chain hydrocarbons, which are less useful, into a short chain hydrocarbons, which are more useful. Yes, and there are two types of cracking. One is catalytic cracking and steam cracking. Catalytic cracking. What is catalytic cracking?
It's when they use a
Catalytic cracking is when you use a catalyst to facilitate the breaking down of a long-chain hydrocarbon. A catalyst is a compound that is used to speed up the reaction, but itself it's not used in the reaction. Yes? Catalyst, yes? Catalysts provide sort of, we're going to do it, sort of energy in it. Exactly. You have done that before, yeah?
Reduce the activation energy.
Activation energy. We are going to look at activation energy later.
Reduce the gas.
You did in your class. Yes. We are going to look independently. I'm better than your teacher. Because when I teach Alima Lot, he got a very good mark. Even Akim. Okay? So, there you are. So, it's steam cracking and catalytic cracking. When you use catalytic cracking, the catalyst we use is aluminum oxide. Why is it Al2 and O3? Change of valencies. Because aluminum is Al3 plus and oxygen is 2 minus in it. So change of valencies. Change of valencies, yes. So this is called cracking. Now quickly, distillation. Fractional distillation. The word fractional, what does it mean? You can read this and understand. Okay? Fractional distillation, okay? No. Fractional distillation. Let's go on. Distillation, okay? Now, fraction means